Okay, so then welcome aboard, everyone. And we are here to unpack our grade 5. We're looking at moving ourselves right towards the end of February, although we meet a little bit before that again. So we will actually probably revisit some of the things that we start in February, namely fractions. We're going to come back to those again just because I know that it'll be a big one at that time of the year. So wanting to keep everything ready to go. So welcome aboard. My name is Chris Arski, for those of you who are new and joining us. And we are in our third session for unpacking the new grade 5 curriculum. So without any further ado, let's get going. I'm going to begin with our land acknowledgement. And we respectfully acknowledge that we are situated on traditional lands across the province of Alberta, home to many First Nations, including the Cree, Blackfoot, Métis, Nakota Sioux, Saulteaux, Inuit, and many others whose histories, languages, and cultures continue to influence our vibrant communities. So we are going to really look again a little bit more at the numbered outcomes, because as we started this year with unpacking the new curriculum, we said that we would be scaffolding those outcomes through. We're not just going to launch right into whatever the outcome said. We're going to take our time to make sure that students are in fact up to the value that we're trying to get them to. And by value, I mean really seriously talking about if your target goal was 10,000, for example, we're not starting there. We need to make sure that the students were mastered at 100 or 1,000 or whatever our starting point was. And so our hope was that we would be done sort of bridging all of those conversations with students to really sink our teeth into the outcome itself for the grade by sort of February, even if it was mid-February and February. I think from what the few that I've talked to from this group, most of you are kind of on board or on track with that as well. But again, we're going to have to do that with each of you have different groups of students. And so you need to judge based on where they're at. And certainly if you can go faster than that, that's great. But what the point was is that we would have that time then, almost the better part of half of the year, to go through and really solidify their understanding in those outcomes. And that's our whole goal, is not to race through and say, check, we did this and we did that. It's more as it's the understanding. And hence there wasn't any chapters to work on. There wasn't any units per se that we said we're spending 2 weeks on this and 3 weeks on that. It's really you're revisiting and you're connecting the pieces that fit together fairly well as far as trying to sort of scaffold the learning as they go along. So we would be drawing questions, we would be integrating activities that come from multiple different learner outcomes. So not necessarily even all from the same learner or organizing idea. Get that one straight today. So in grade 5, we know that they're coming out of grade 4 with mastery of their math facts of 12 by 12. And we know that clearly there's still work to be done there. So that's definitely still got to be a forefront. It's got to be a daily kind of thing where we're practicing. And then the other piece is that research has shown us that students, and I think anyone who's taught for a number of years, you know this, you don't need research to tell you that when the students come back in January, although they've been off and they've had Christmas, that January, February is a long time frame for everybody. And sometimes they disengage more than they have been before. So our goal is to keep revisiting, but not to just keep doing the same old approach. Maybe we need to put in some new or some newly old types of games and activities and engaging ways of, sort of presenting that material to them. They don't know that they're revisiting an outcome. We do. That's our job. But what they're getting is, I have this lesson, and if it looks the same as it all did before, then I'm not necessarily going to be that thrilled or engaged in it. But if I can revisit maybe some old activities that I did at the beginning of the year, and now that I'm doing them in light of some newer targets and goals, then it isn't going to be the same for them. So that's also part of our sort of keep in the back of our minds, how else can I engage the students? And keeping their interest, and as I keep moving around and moving through these organizing ideas again. So we had said sort of right up front that money was one of the things that we could use for many of the learning outcomes that we had to work with on the students. And more so not because it's just a tool that I can use to get to an end of a learner outcome. It's engaging and it's real. That's the most powerful piece of that, is that this is a real world context, which happens to be one of the tools right now that we can really leverage and use for addition. We can use it for decimals. We can use it for understanding a place value. We can use it for determining place value. And when I'm lining up decimals and what the value of decimals are, because you're going to go to thousandths in grade 5. They've done tenths and hundredths in grade 4. So how do we unpack that tenths and hundredths? Do we simply say to them, oh, well, you know that the first number behind the decimal place is tenths. And if I was dividing by tens, this is what it would look like. And if I was dividing by another 10, it gets to the hundredths, and this is what it looks like. All true. But if I'm not a student where numbers resonate in my world, then that really just means nothing to me, right? I want to make sure that we're getting to understanding at the same time. Is it always going to be perfect? No, but we do want to make whatever attempts we can to make it as real for the students, so that if they can close their eyes and they're stuck and they close their eyes and they can envision something that they were doing, we've done our job, because now they have a fallback. They have another personal strategy that they can fall back on in order to move themselves forward, instead of just shutting down and walking away. Okay, so enough of my soapbox on that. I know you guys have heard that more than once. So I do want, I'm not going to go through every one of these lines, but I just want to highlight again how, as I opened, what we were basically saying, and the fact that we often have seen in our year at a glance that we were doing, and again, this was not mandatory to do it in this order, that you're seeing the same outcome come up over and over and over again, because we're working on the same one over and over throughout different kinds of activities and different approaches, but the targets change. So those pieces in yellow where we said maybe just start with, and then we start to scaffold a little bit more, those are changing. And each month that we move forward, we see more and more of those changes come into play. So as we're going through, we see that we have 5N1, which is basically analyzing patterns in place value. And that's a really crucial one, especially if you want to start talking about thousands. I need to make sure that they're solid on all of those place values and not just memorizing. It goes ones, tens, hundreds, thousands. We want it to be deeper than that. That's just the surface level kind of stuff. We need deeper thinking and understanding. And do I know the difference between the position of a digit versus the value, right? That's another conversation we want to have. We also said for 4N2, students add and subtract numbers. They're going to be going to 1,000,000, but we're not starting, and we didn't start in September with 1,000,000 because that was a huge leap for a student. So we just said, start small, start at 100, and make sure that they're all mastery of 100. And that's the rule that we kind of used all along, is mastery of 100. If they can get 100, then going to 500, 600 isn't a big step. Going to 1,000 becomes a fairly easy step. But if I'm struggling to even get the addition and subtractions, I can't regroup yet, I can't even get to 100, then moving me up is just going to give me more frustration and doesn't guarantee that I'm going to learn any more than I did when I'm still stalled at the same place. So that mastery to 100 was important. We said the math facts of 12 by 12 would be something that would be daily. Find engaging ways to do it. You're subitizing cards with those activities that we did at the beginning of the year. Those should be your 5-minute blessing every day, just to watch their excitement to do that. But also, they don't need to know that that game is actually learning. They're teaching themselves their math facts. And if they don't know them, that's okay, because they can always count the dots, but they're only going to count the dots so many times until they say, I just count, I know what this is. And they do. I've seen that, and I've seen the benefits of it. So really, really want to find ways that we can always engage them in learning their math facts. And they also need to know what those math facts look like and why are they the way they are. And that's the other piece is, are we just giving it to them and saying, go home and learn them because you're supposed to have known them before? But maybe I'm not learning them because I can't even envision what these are. They're just a bunch of numbers with a time sign in between. But really, what are you asking me to find here? And so reminder, that every time we ask a student to do a multiplication of any kind, that reflects an area, an amount of surface that they have covered. That's really what they're finding. So they need to see that. So we'll do a little bit of work on that today. So we saw that those just carried right through, right into November, which we just finished. And as we start moving into December, we still see 4 and 4, or 5 and 4, sorry, in our ballpark, and we're going to see it for a while. It's going to come back, but really, students are multiplying, dividing natural numbers within 100,000. So now, if I'm multiplying and dividing, I need those math facts, right? That would be helpful. That being said, the process of multiplication and division is a separate process from me necessarily learning my math facts. And it's not fair to say, if you don't know your math facts, I can't really do this multiplication and division with you. Then I need to find a way that they can get into the multiplication and division process, even if I'm weak in my math facts. Either I give you the tool, I give you the math fact table where you still have to look it up and figure out what it is, or I give you another strategy. So today I'm going to explore the other strategy, because what we normally do, I'm not too worried about. I think everyone's got those well under their belt. It's just, what else can I offer them? What else is out there that might make sense if they're struggling? So we'll look a little bit at that. We're also going to look at 5 and 5, which is that introduction to fractions, not introduction for the students, because in a perfect world, they've been doing this now since grade 2. They did grade 3 unit fractions, really did that a deep dive in there. Grade 4 is really built on those unit fractions for you, because in grade 5, they need to have a really good working knowledge of a unit fraction, because that's going to help you with the multiplication. That's going to help you with pulling apart, decomposing, and composing a fraction. But if I don't understand the unit fraction to begin with, that's going to be a struggle. It'll be at best a memorization, and it'll only be something I'm familiar with. And after that, if you throw a number at me that I don't know, I'm just gonna quit. I don't know what to do here. I don't understand where you want me to go with this. So we're going to try and just revisit the unit fraction a little bit. We know this year probably that's not going to be negotiable. You're going to have to find out what they know about it, and not go back and reteach all of grade 4, because you can integrate a lot of what they need to know as you're unpacking the grade 5. But they do need to know that, and it will be helpful. So we'll do some activities today with that. I'll show you some, and again, depending on where you are, and some of you have already started fractions, some of you've parked it until after Christmas, whatever. Okay, we'll just throw some ideas out there so that when you do get to that point, we can give you some personal strategies that you can use with the students. That being said, that will be one that I will revisit when we meet in session 4. Because there are some other pieces to fractions that we just couldn't uncover all in one shot today. The other thing is that we're finished pretty much. We had started doing algebra quite early on, and we also said that we would start to make sure that the numerical algebraic statements that they were working on, expressions, would be done pretty much sort of by the end of this month. So we'd be finishing up doing the order of operations where you're doing brackets, you're doing addition, subtraction. So we want to make sure that the students are really clear on those pieces. So when we talk about the parentheses, those are the brackets, and we want to make sure that they understand what those mean. And we're going to offer you another way to maybe show it to students. Again, if the numbers mean nothing to them, if it just really doesn't sit well with them, maybe we can show them how it might look for the order of operations with Cuisinart rods. So we'll do a little bit of work with that. So we're finishing that, and then we're sliding over to algebraic expressions. So the difference there will be that we're going to introduce variables. And we're kind of targeting to start that around February to see where we can go with that. So let's look back at 5 and 4. It's really the multiplication and division. We're looking at multiplying, dividing natural numbers up to 100,000. And they're saying, and including the standard algorithm. So remember, it says including. So that means we would have that as one of our strategies, but it does not say only. So you need to find those students who that's just not working for. Doesn't mean we don't keep trying with them, but on the same token, if that standard algorithm is just not resonating with them, what else can we show them that would give them success in multiplying? Still let them find an answer on a PAD exam if that's what they were going to do, but that they would have success in this, even if I don't know my math facts, right? I need to have some strategies that I can use. And I might be weak in them, but maybe I know some of them. So provide some additional strategies. And we do have in this slide deck, there's going to be a number of slide decks. So they're embedded inside. So it's not just the one that you're seeing here. So whenever you see a hyperlink, there'll be a number. So as you get to it, it doesn't have to be right when you open this one up. As you get to that section, you might want to go and revisit some of those slide decks again. So one of the ways, and we did cover this once before, but I just wanted to touch on it now in case you're new and hadn't seen it. One of the ways that we could do is certainly multiplying. And if I'm just double checking that they know some of their basic multiplication, I mean, 2 by 2 multiplication by now should be solidified for them. That shouldn't be a big deal. At the end of grade 4, they're working on 3-digit by 1-digit. That would be your starting point. Do they even know 3-digit by 1-digit? And if you're not sure, do 2-digit by 1-digit. And I say that because you'd rather have them have 4 or 5 or 6 super successes, and they turn around and say, this is really easy, before we launch into a bigger number, a 3-digit by 1-digit, 2-digit by 2-digit. So we want to make sure, but the 2-digit by 2 should be something that they've got. And if not, but I would check. That's one of the pieces. So what are some strategies that I can use for 2-digit multiplication? Well, I can use the standard algorithm for sure, and I won't go through that one. I could also use my base 10 blocks. And some people turn them up. This is what I call an upside down L. So here's an L that comes across the top and down the side. And up here, I put my factors. So the number that they're asking us to multiply is 31 by 22. So 22 is made up of 2 rods and 2 units. And then down the side of my L, I'm going to put 31. So I need 3 rods and 1 unit. I tend to do it the other way so that I can build up and so that students can see. I turn it over, so I just make a big L on my sheet, and then they fill their factors underneath and up the side. Whatever works for you, doesn't matter. But if you've never seen this process before, basically the outside of your L is the factors, the numbers I want to multiply. And whether I put the 22 on top or on the side doesn't matter. Okay, won't change your answer, just changes the way it looks. The inside of the L is your answer or your product. And that's our goal. I want to know, what is the answer? What's the product that I get here? So in this case, when I'm doing this multiplication, anytime I have a rod times a rod, or 10 by 10, that's my grade 3 multiplications, I'm going to get 100 or 1 flat. So wherever I can match up my rod and rod, I get a flat, a flat, a flat, a flat, a flat, a flat. And if I was counting those are all hundreds. Easy to count by hundreds. Down here, I had a unit, and I needed to multiply the unit or find something that is the same width as the unit, but the same length as the flat. And what fits that is our rod. Our rod is exactly 1 unit wide. It's made of 10 units, and it matches the side of the square. So I need a rod here to end up with this one, and I'll need one up here so that it matches with this one as well. And the same thing would happen if I could just turn it over. The same thing's going to happen here. I need to line up a rod here and a rod here for each one of my flats. Your goal inside the answer is to build a rectangle or a square. No holes, no gaps. So I have this part built, then I would have this hole up here. And I can't fit a rod in there. I definitely can't fit a flat in there, but I can fit the 2 units into there. So then my answer becomes 1, 2, 3, 4, 5, 600, because they're each 100, 10, 20, 30, 40, 50, 60, 70, 80. So 680, 1, 2. They just count them off. For a lot of our students, that's really important for them to see. It's really important for them to have that opportunity. And that makes lots of sense that they can see it. And remember, I said that a multiplication is an area. There's no number you can give me that you could multiply that doesn't represent amount of surface that was covered. So now they can even see how much surface was covered on the page with those 2 numbers. So that gives them a visual of what a multiplication table is. And just random numbers multiplied, they're actually areas. They're finding areas. Okay, so there's another example over here, and they could fill those in and they could do it that way. So in this case, they will get their two new numbers that they're multiplying, and then what is their final answer. So I'll leave that one for you just in the interest of time. But one of the other ways, besides base 10 blocks, and they're really good, but the base 10 blocks are excellent for 2x2s. You could do a 2x1, like a double digit and a single digit. It's just, it's very time consuming to fill in all the little rods and all the little individuals. But when I want to do 100 times a 2-digit, then the base 10 blocks don't work as well. So in this case, I might go to the box method. And this is, without a doubt, if you give students, and they've been seeing this, if you give them choices, more than not, they go to the box method. They love it. They like the way it's easy for them to maneuver, and it chunks out the numbers. Nothing really different than what the base 10 was doing, only it allows me to do larger numbers. So if I had 17 times 439, I could take 439 and write it in expanded form. So 430 and 9. So 400 is here, 30 is here, 9 is here. And I was multiplying it by 7. So 17. 17 is the same as 10 and 7. So if they're not really super struggling, then most of them will know that 400 times 10 is just that number with another 0 at the end, so 4,000. The numbers of 1, 10, 100, 1,000, those are easy for students to learn, even if I don't know any other multiplication tables. That's one that they learn quickly because of the pattern that comes to bear. We're going to use that knowledge in division here right away. And it doesn't matter which way I turn this. So I'm going to work each one of these out. 4,000, 3 times 1 is 3. I'm going to add 2 zeros, or 30 times 10 is take 30 and add a 0, so 300, and so on. And then they can just simply go through and add these up, or they can put them down on the side if they need to add them up that way. But for some students, the box method is perfect, but this is even still too much for them. They can't handle that big a number. They can't handle 400. They could handle 100 because they know what the pattern for 100 is, but they don't know what to do with 400. So some of them will break it down even more. And if that's the case, that's absolutely fine. Let them decide and let them kind of work their way through. So on here, there's a video to show you again how to do the multiplication with the base 10 blocks if you forgot and haven't got access to this video. So this is hyperlinked in here. Here's another one with the box method. And I'm going to go down here into multiplication and division just to show you some strategies similar to the one we just did. You have this access to this one as well. So you just have to click on the link that's in your slide deck. So again, I have options that I can do. And in grade 4, they ask students, 4 and 4, to investigate what happens when there's multiplication division by the numbers 10, 100, 1,000, or even 1. And those patterns, like I said, we're going to use for division right away. But I could use money and make that visual. Instead of just asking me to memorize that it has to be a 0, I can see it. So here's 110. So 1 times 10 gave me 10. If I had 2 times 10, I had the base natural number times 10, I got 20. I had 3 tens multiplied by 10, I got 30. So I'm kind of seeing a pattern that the natural number simply gets a 0 added on to the end when I'm multiplying by 10. And I'm going to keep doing this until I get down to the bottom. Then I'm going to ask them, anybody see a pattern? And it's not a difficult one. Even our struggling students come up with the correct answer there. So let's check your pattern. You said your pattern was the number and then just add a 0 to it. So where 8 times 10 you're saying would be 80. Well, I can double check those by simply counting out 8 tens. What pattern is there if we were to multiply by any number by 10? And now we should be able to generalize it and say it would be that base number, that natural number in this case, with a 0 added on to the end of it. What would 9 times 10 be? What would 10 times 10? And sometimes this one gives them trouble because it ends up in a 3-digit answer. But they could prove it to me. You know, you think, oh, you're wrong? Well, just double check. Or grab 10 tens and count them out. So having money available to them just to grab would be really helpful rather than sort of wasting time going to get a bag or whatever. Just to have it out when we're doing any kind of work like this, just have it available to them. So how could I check, verify? I could count them out. So now let's move the idea that you just generalized for me to hundreds. 100 gives me 100. 200s gives me 200. Through 400s or 500s gives me 500s. And what's the rule? Well, it's the base number or natural number. I'm going to add 2 zeros to it. So again, that's a quick understanding for them. And any number that gets multiplied by 100 would have 2 zeros added on the end. We won't worry about decimals right now. We're just talking about the natural number. And so when I talk about this moving to 1,000, they're pretty quick to realize that it's going to be 5,000, 12,000, 1,000. We want to remind them that 12,000 isn't 12 comma 00. It's 12 with a space and then 000. So these general rules are ones that students can handle regardless of how much I struggle with math, especially if I write those pieces out. Here's some quick questions that you could ask them. I wouldn't ask them to write them down, just do them orally. Just make sure that the class has got what they want. But in this case, I want to leverage some of that to do some of the work that we have to do as far as multiplication and division. And I want to address it specifically for the students who are struggling. So if I look in grade 4, one of the things that they had in grade 4 was 4 and 4 students multiply and divide natural numbers within 10,000. Multiply and divide a 3-digit by a 1-digit. So that's what they're working on. So that's a logical place for us to start any kind of big multiplication is 3 by 1, because it's the natural end of 4. So that should be the natural start for us to do in grade 5. If you are doing and modeling any of the work for the students, ensure that we use proper vocabulary. In other words, don't just say, I'm going to write a 2 down because it's 22, and I'm going to carry the 2. You're carrying what 2 is that? Is that a 200ths? Is that 2/10ths that you're carrying? So if we could name it, then the kids start to get into the habit of naming it themselves, but also it helps to align then their thinking about place value. There is a quick little video here, which does a 3-digit by 1-digit. Want you to, and has some really good ideas about, what they do on the side, but I do want you to listen to what is the explanation that they're getting, and is there anything that you would add to it? It's a great video.
Let's multiply.
Suggesting it's not a good video, but it has some pieces in it, if we're going to be consistent, that might get added or expanded on. So what if the number was 253 times 7? I might be a student who just wants to break up those numbers, those big numbers. So I'm going to go 200 plus 50 plus 3. So I'm going to use expanded form, which means that each one of those numbers will get multiplied by 7. But maybe I look at this and say, that's too big for me still. I don't like it. So I'm going to break out 200 into 2 100s, 2 times 100. And I'm going to break this one into 5 times 10, because I like multiplying by hundreds and tens and thousands. It's easier. So if each one of these is going to be multiplied by 7, I might know this. Even if I don't know all of mine, I might know this. I might know my 2s, because 2s are pretty common for kids to know. So I might say to them, you know your 2s. What's 2 times 7? And if they go, oh, then just what's 7 plus 7? 14. Okay, so then you do know what 2 times 7 is. 2 times 7 is the same as 7 plus 7. So I could write that down, and then I know what I'm going to do when I multiply by 100. Same thing over here. They might know their 5s. If they don't know their 5s, we're going to use our fingers and just count them out. Count out 7 and let them count them out. Skip count by 5s. What are you going to put here? So we just move forward with the multiplication table. You leverage it wherever we can. And I might know what 3 times 7 is. Maybe I went 7 plus 7 plus 7, whatever. They might want to do an addition on the side. Depends on how strong they are in their mental math. But this is, again, an easier one because there's no regrouping involved in it. But again, that might be over the tops for some students. They prefer a box. So again, they might take the number and break it out into the box, leave them whole. Or they're the student, I would prefer the hundreds and the tens. So they're going to write each one of those in the box. And I would go 2 times 7, 14 times 100. So this would be 14,000, or sorry, 1,400. And then I would do the same thing with each of these. However, I will say to you that for some students, even this is too much. And they're still going to be really successful. But you might think, oh my God, how many more boxes can you add to this? And the answer is whatever it takes. If it makes sense to them, and it doesn't take as long as you think it would be to draw them, because they're just doing it on rough paper. So I don't care whether the lines are straight or not. I care about how they divided up the number. So some students will take that 2 times 100. There's 2 hundreds there, and just give each of the hundreds their own box. This one said there are 5 tens, so I'm going to give each one of them their own box. And I might leave the 3 the way it is, or some students will make that a 1, a 1, and a 1, so add 3 boxes. But what they're really doing is they're saying, I can handle this. I just can't handle anything else that goes with it. So 100 times 7, got it, 700. 100 times 7, got it, 700, and so on. That's manageable. And how they add it up on the side is entirely up to them. Some do all the hundreds first, some do all the tens. Again, there's going to be some regrouping there, but that's okay if this is the way it works for them. Some students will say this 7 gives me big numbers here. And I don't know what to do with 700 plus 700, like that's too much. And it's not for us to say, come on, you should be able to do a 7 plus 7. Yeah, they should be. But again, math isn't everybody's forte. Some students will take that 7 and put them all into ones. Why? Because 100 times 1 is 100. 100 times 1 is 100. I can skip count and add hundreds in my head. That I can do. So then they're just counting up the hundreds and the tens just like they did with the algebra tiles. Again, you might think this is crazy. How would you make it so big? But they do these so quickly. And eventually some of the students will say, you know what? I can do 2s. I'm going to put 2s here instead of 1s. Fine, that works for you. Knock yourself out. But they will do and get the right answers. We just have to be patient with them to give them. And it doesn't mean that they're going to take triple the time. If they get it and you say, you can use the box method, we're going to have to pick up the speed here. So make sure you don't spend too much time. I don't need a ruler here for these boxes. I just need to see, are you being able to break the numbers up? But now we're going to flip it. Most students love to add, love to multiply. Don't like subtracting quite as much. And the research and stats show us that. Just kids don't typically do as well in subtraction as they do in addition. Well, the same thing is true about division. Most people hate division. They would rather grab a calculator, their phone, or whatever. But again, we're not allowing you to do that all the time, and that might not be available. So you have to have some strategies on how you're going to do this. So we're going to leverage that same understanding that we did just now with the ones, tens, hundreds, thousands. We'll go as far as we need to go. So the question was 868 divided by 7. So over on my side, I'm going to make that legend using my 1, 10, 100. So 1 times 7, 7, 10 times 7, 70, 100 times 7, 700, 1,000 times 7, 7,000. Oh, 7,000, way bigger than the number I have. So I'm going to cross that one out. I'm not using it. So here's the 3 that I can start with. And I'm going to try and grab the one that gives me the most out of this number that I can take away. So I'm going to place the 100 because I'm going to use the 100 one, 100 times 7, and we're just going to put it down the side. And that gives me 700. I just subtract, no regrouping involved. I'm going to go with 10. I can't go with another 100 because there's not enough numbers, but I could do a 10 because 70 is smaller. So I'm going to subtract to 70. I get 90. I'm going to do another 70 because it's smaller, and I get down to 28. And maybe they know what 4 times 7 is 28. Maybe they don't, and they do 1, 7, 1, 7, 1, 7, 1, 7. And that's fine. All I need to do as the student then is add up everything I used on this side of the column, and I will get the right answer every time. I used to do this only with small groups of students, but we had some classes that I was in where they were listening. All the class was listening, and they were watching to see what we were doing. So we showed it to all the students. Some of them just love this. And I mean, they're not students who are struggling. They don't really need an adapted version of any kind, but they loved it. They thought it was the way to go. Whatever works for them, I'm fine with that. So this would be another question that we could ask. And as I start doing these with students, especially if I'm working with small groups, I will ask them and nudge them. You know, do you know your 2s? I think you know your 2s, especially when I've got something like a 5. So I might say, what's 1 times 5, 2 times 5, 10 times 5, 20 times 5, right? I can do a little bit of bending in there because then I don't have to do so many of them. And inherently, kids will do that on their own. They'll start to separate them out and go into those. So these are just examples of the same things that we just talked about now. They're not anything different. So I'm just going to go out of this one and come back to our main slide deck. So you have this. You can use it if it helps you. If not, It's one that we shared with the grade 4s, but it works right now for pretty much anybody in Div 2 that's struggling with multiplication. You are going to be doing decimals because they do decimals in grade 4. So a lot of times when we do decimals, we say to students, just ignore the decimal, multiply 34 by 4, and then we're going to count the number of places behind the decimal and put it in. But maybe we need the y behind that too. Maybe kids need to see that. Maybe that still isn't working for me. So decimal 34 means I have 34 hundredths. And if I have 34 hundredths, it's like saying I'm filling up those 100 pennies on the cent side of a dollar to work my way to trading it for a loonie. So in this case, I could take 100 squares and just put them side by side, and I can simply fill in decimal 34. And what this is saying is you have 4 groups of decimal 34. So in this video that's here, you'll see them fill in the 4 different colors of decimal 34. And then as I fill 100, I already know that that's a 1. And then I can count up whatever I have over here that's been used. So that's another way for multiplication of decimals that students maybe need to see. Just might make more sense to me. I get that. I don't get something else. We had talked about coordinate geometry and geometry early in the year. It was one of those things that we said could be finished pretty much by the end of October, mid-November. And it would be to our benefit to tie the symmetry of the, or taking the, sorry, not symmetry, the shapes that we were working with in geometry at the time and use those on the coordinate grid and use the corners, the vertices of those, just have the kids start practicing labeling coordinates. Now remember, the coordinates in grade 5 come in at the very end. They're not the first thing you start with. You're starting with movements. You're talking with comparative language. You're saying up and down, left and right within that coordinate grid. You're maybe have a target. Get out some old maps where it used to go A7 and you could find whatever it was you were looking for. Kids love that. They think that's a hoot that we used to do that even with travel maps. Find some that have that on there and show them. That is the coordinate geometry starting point. But in the end of it, we are going to get to an X, Y axis with a coordinate of X and Y in a coordinate grid. In other words, quadrant 1. There's no Cartesian plane in grade 5. And then as we start moving into grade, down into the geometry again, we could revisit it. We could be done, but we could revisit it again when we want to talk about symmetry. And they did do some work in symmetry already, and we did kind of sort of pack that away. But we're going to bring it back out. So the revisit of organizing ideas, the revisit of learner outcomes can come just at a teachable moment. You see it, grab it, ask the question. Just because we're not doing geometry right now, we were doing multiplying, doesn't mean that I couldn't ask the question. And then we have our algebra pieces in here that we're going to look at as well. So we will be unpacking a little bit more of the 5N5. We're going to do that right away. We're going to talk about fractions, but notice what the verb is in your sentence or in your learner outcome. It says interpret. It didn't say stand up and deliver, that the top number is the numerator, the bottom number is the denominator, and this is what they mean. I need them to figure some of that out on their own before we kind of launch into that sort of direct teaching approach. So they need to be able to interpret what they're seeing and make some sense of it and explain that to you. Remember, these bullets are your understandings, right? They're not the pieces that you're teaching. So if I go back to the algebra first, because we just have this on the bottom here, they're going to do algebraic expressions. I want students to know what an algebraic expression is. But before I do the algebra, let's revisit, did they finish their numerical expressions? So here's an example of a numerical expression that we're testing. We want to know, is 2 times 3 plus 2 the same as 2 times 3 plus 2? And I moved the brackets. That's all I've done. So how could I model that so that they could actually see it? So if I'm the kid who needs to see it, this is one way for me to see it. So I need to do the brackets first. So I need to find a 3 plus 2. Well, I can use my Cuisenaire rods. Light green is 3, red is 2. I have 2 groups of 3 plus 2. So this is what you're seeing here. And then I would ask, wow, you know, could you, when you put those together, is there one block that could just fit underneath those, or do we have to stay with the 2 of them? And of course, they're going to find that the yellows fit under there because they're 5s. What happens when you put those 2 5s together? Because this is supposed to be one question, it's all told. I would get an orange, and an orange is equal to a 10. So the question is, will they get an orange or a 10 on this side with the change in brackets? So this time it says find 2 3s, 2 groups of 3. The light green is the 3. So here's 2 3s. And to that, I want to add a 2. So when I take the 2 groups of 3s and put them together, I get a 6, which is the dark green. And to that, I'm going to add a red one. Well, if I added a red one onto the green, well, that's really going to be the same as one large brown. So in the end, I ended up with an 8. I didn't get an orange, I got a brown. So no, they are not equal. So you can use your Cuisenaire rods to help students to understand the visuals behind the order of operations. Clearly, when we do exponents, it's not the easiest thing to do and probably would stop at that point, which is grade 6. But up until then, there's nothing stopping us from using them. So there's a couple of other questions here that you could model for them, or you could do with them, or they could do. And then I did give one that was a division one as well. Okay. So if you haven't got Cuisenaire rods in your school, which I will highly doubt, I bet they are the best kept secret in schools. They've been around forever. In most cases, they're sitting on somebody's shelf and nobody knows what to do with them because they don't know what they are. So go have a look if you've never seen them and see if they're around. But here is a link for a virtual one that this is how I made these. So if that's of help to you, then by all means use that. So let's have a look now at interpreting those algebraic expressions. How do I start unpacking some of the terminology that they have to learn in grade 5, which is the new shift from grade 7, because we used to do variables and constants and expressions like that in grade 7 as well. So I have another slide deck in here for you. And again, you're welcome to use it, not use it. Maybe you've already done it or you did it differently, and that's fine. This is just one quick one that you might be able to use. And what we're trying to do is get them to understand what it is that we're talking about that's different from numerical expressions versus algebraic expressions. So algebra means I'm talking about variables. So I might start with something as simple as this. You got pattern blocks in the school. What if I put something like that out and said, how would you put these shapes together? What would you do? And most of the students were going to give you, I'm putting all the things that are the same color together. And that would be kind of the logical way that most of them are going to go anyway. So the yellows are together. They're yellow, but they're also the same attribute. They're hexagons. I have all the reds together, but they're also all trapezoids. And I have the blues together, but they're all rhombi. So I have put together these different shapes based on color and their number of sides, their angles that are in them, and so on. But what we've also done is kind of introduce them to the notion of when we get to a like term, a like variable, this is really what we're saying to them. So if they get lost along the way, say, remember the day that we put those hexagons together and the trapezoids together? I want you to remember that because that's what we're doing. This is it. So it gives them the same notion. I have same color, same shape have gone together. So this they've done. They can do that with brackets and whatever else that we've done. But really, this is your numerical expressions minus all the brackets and multiple steps. But I can figure out the answer to this. That's not a big deal. But in this case, if I wanted to change this from numerical to algebraic, then I might want to cover up one of the numbers anywhere in those expressions with a rectangle. Or maybe the rectangle is going to be a letter, or maybe it's not. Just leave it as a rectangle. But what I've done is I've simply said I've changed it from a numerical expression, which has a concrete answer. There's no if, ands, or buts. The answer here is 11. It's not close to, it's not over, it's not slightly, it's 11. But the minute I put this in, depending on what I put in here, because the rectangle doesn't tell me, and it's just saying put in whatever number you want. Well, I'll put a 1 in. Well, I got 1 plus 7 is 8. I can put 3 in. Oh, I got 10. So that's why we call it a variable, because it allows the answer to vary from what it was before. So I typically don't use shapes or the variables, although there's lots of starting worksheets that you can find that are just shapes, I'm going to replace it with a letter. And just an FYI, whenever we use letters in algebraic expressions, the letters are lowercase and they are italicized. That's how they see them on a pat and a dip. That's how they're put into text form as well, just so that students don't get confused with an X in a question, right? So it just does look a little different. So always lowercase italicized, and we point them out to them. You know, these X's were like our yellow hexagons, and the Y's were just like our trapezoids. And the M is just like our rhombus. So that every one of those letters had a different shape and a different color. They're not the same. So that's what we call an algebraic expression. It has a variable. It might have an operational sign and a number at the end. It might not. It can just be a variable. It could just be a number. But in this case, x plus 6, the number itself is just going to take me back to a numerical expression. But I don't have to have a letter to be an expression, right? So in this case, x plus 6, I have the variable x. It's the placeholder for whatever number I'm going to put in there. I have a number, which is never going to change. Everything's always going to be plus 6. So that's called my constant term or my constant value. And then the operation sign could be add or subtract in there for now, or multiply and divide as well. But we're going to use this for now, just as an example. So those variables are italicized, right? We just want to make sure that students are clear on that. So let's go, and I did these deliberately in capital letters, just so they were big and bold so the kids could see them. If I said, you have these letters that are up on the screen right now, how could you put them together? What would you put together? So it's not a difficult task. They're going to say, put the M's together and put the X's together. Good. All right. How many M's do we have? And how many X's do we have? So they're going to go 1, 2, 3, 4, 5, 6. There's 6 M's. And that's important because we want to get to another statement that was in your column of skills, procedures, and knowledge. So I have 6 M's, and to add them, I would have just gone 1, 2, 3, 4, 6. So it's like saying I put them into a sum statement. And I ended up with how many? I ended up with 6 M's. I ended up with 6 X's by chance. And so when I write the M's, it's not 6 times M. I had 6 M's. As I say it is how I'm going to write it. And that is one of the explicit statements, is that when you have a coefficient and a variable, we do not put the multiplication sign in between. When they sit in front like that, it automatically implies multiplication. So as I said it, 6M, there you go. How did you get 6M? Well, I had added 6 of them together, or I went 6 times one of them and I got 6 M's. Same thing with the X's. How could I write them? So then I might go a little bit further and I might ask them for something like this. I might say, here's a question. And if I were to add things that are the same together, what would they be? Well, I could add the X's together. And if they look at you and say, I don't know, I'm lost, then we could ask them, how many X's are sitting here? 4. Okay, let's just put X's all over our page. Okay, put 4 of them out there. How many are over here? 6, put them out. So just take them back to that same kind of demo that they saw first and let them work their way backwards. So what I'm seeing is I can put my X's together because they're scattered all over the page. I had groups of 4 and groups of 6s. When I add them together, I get 10. Or I noted that really when the letter was the same, the variable, I could just add the numbers that were in front. I got 10 of them, and I can prove it by counting them. I have a constant number 3, a constant number 6. 6 and 3, we know how to do that, is equal to 9. So I can take this expression and reduce it down into its simplest form of 10x plus 9. Okay, we could ask them another one. It doesn't always have to be addition either. So in this case, I've got 7m plus 4 plus 3m take away 1. So I'm going to put the m's together. I'm going to put the numbers together because that makes sense to me. And I've got things that look the same. So then in this case, I'm going to ask them, what is our final answer? So again, I'm going to add my m's. I have 10 of them. I'm going to subtract this time and I get 3. So this is how we can introduce the algebraic expression and give them lots of practice. Like, it's not hard and they find it fairly easy once they get on a roll, but they do need the practice. And the day you do it, they're going to excel. The next day, come back, revisit, because They don't necessarily carry that one over. They need repeated practice at it and to get good at it. What we want them to realize, though, is that you can't add two different letters together. So if I go back to this one right here, I can't say what happens when I have 6 M's and 6 X's. If I wanted to add them together, what would I get? And the kids will, some of them will tell you 12 XMs. And I'll say, X isn't a letter of the alphabet. M is a letter of the alphabet. Where did you get the XM for? Because I've never seen that in the alphabet before. Just putting them together, it doesn't automatically say we can smush them together and come up with a new one. We couldn't take the yellow hexagon and jam it into the red trapezoid and come up with a new block because they're not the same. So that's that conversation we need them to have, because that will be their first common mistake that they make, is that they'll want to just combine the letters. And so they need to understand why they can't do that, and that they can't just create something. And that's really what they're saying they're doing. So we unpack this and we get lots of practice at doing those. Okay. So that's there if you wish to use it at the point when you get to those. But again, I want you to be really careful too when it says express, recognize, write. Okay, they have to do those. It's not a matter of just looking at a bunch of pages and pictures. They actually have to do them and express them, or put things on the table, give them pattern blocks where they can represent an expression with a pattern block. That's a really good deep question. It also gets to the understanding. Measurement is something else that we're going to spend a little bit of time on, because we're going to talk about measurements that some of them are going to be in a context where I don't have a standard measure, but I still want to express a measurement. So I'm in the Clark office right now, and if I was to say, how far is it across the room? I don't have a tape measure, I don't have a ruler, I don't have anything. I might have to say, I'm going to lay down, I'm going to put a marker, and then I'm going to keep doing that. And I can say it is like 6.5 of my body lengths across. Whereas if my partner Ted from science was here, who's much taller than I, it might only be 4 across for Ted. And that's the problem with non-standard measures, is that we're getting a correct measurement based on the unit we used, but it's not one that's easy for the students to align, because we're two completely different heights. So I still don't really know how exactly far it is across. So that's why we develop standard measures, is that we have that common language about a distance or a measurement that's being expressed. And we're looking at rectangles have area, right? This is going to come into play here. Well, where did we see rectangles before, and where did we see area? We saw them in multiplying. So we're going to bring some of that back again. So in this case, I'm going to try and do some of those measurements of area without telling them length times width. I don't want that to come out yet. I don't need an algorithm just to be thrown at me. That's simple. I can say go length times width. This is a length, this is the width, multiply them, you're done. But that doesn't mean I understand what you're asking me, and it does unpack and investigate and let me explore. So I would give you, there's some good paper in here, and what I would do is have 2 sheets of it, or back to back. And we're going to ask the students to draw as many rectangles as they can that would have 12 squares or 12 centimeters squared inside them. So they can draw them rectangle this way, they can do it long way, they can do a really skinny one that's long. We want them to come up with every possible type of rectangle that would give them an area of 12 inside. Okay, so we don't say area, we say 12 squares are inside. So telling them it's a rectangle gets away from, oh, I'm going to make fancy ones and make a star out of it, whatever. No, we don't want that. We want rectangles. And we're going to consider a rectangle that goes horizontally different than one that goes vertically. And why is that important? Because that also gets to my math facts. It lets me see them differently. So when I do them, and I didn't put them all on here, but I shaded some of mine in, so it's just a little easier for us to see them and look at them. One of the questions that I might ask is, can you count the number of squares long that this is and the number that it's high, and write those numbers all the way around on each one of them? And when you're done, I'd like you to find the perimeter, and let's refresh. What's perimeter? All right, it's the distance around the outside. So how far is it around the outside of each one of these? So we want to get them to find the perimeter. So they're going to label them, find the perimeter. Logical question. They all have 12 squares inside. Do all of them have the same perimeter? And the answer is no, they don't. So that's important for them to realize that I can have the same amount of squares covered. But that doesn't mean that if I started in a corner and hiked around that I've actually covered the same distance in every one of them. So then the next question would be, how many squares were inside again? You can count them if you're not sure. Well, I can see 12. Let's put 12, 12, 12, 12 in all of them. Just want you to see it. And then I want you to look at the numbers that you wrote down on the sides here. So look at one of the ones that's on the horizontal, look at one of the ones that you wrote on the vertical. How do those numbers relate to the 12 that's inside? Yes, I can just tell them to multiply. I want them to tell me that's how they're going to get there. Again, if they get stuck, that they have a strategy. So, and they will figure it out, especially those who know their math facts. They'll say, oh, you just have to multiply these to get that. Oh, cool. All right, great. So we can say that area in this case is how much surface you've covered. And notice we used our math facts. We went, in this case, 6 times 2. 6 times 2, we know our 2's. 2 times 6, 6 times 2, we get 12. So my math facts are actually how big of an area you have used or covered on a piece of paper. And that's an important piece for them to be able to kind of connect to what they're doing. The next step might be, what if I took, well, I'm going to go one step further here. What line of symmetry? Do any of these have a line of symmetry? And if so, could you draw it? Can you put it on there? So in other words, does any of them have a line that you could put in here that you could fold it over and it would fit perfectly? Nothing missing, nothing overlapping. And so that means that they need to see not only the vertical, but they also need to see that there could be a horizontal. And some of the students will say, not on this one so much, but they'll go down here. They'll say this one has a diagonal. And I'll say, you know what, let's just double check that and make sure that we're all on the right track. So why don't you cut out your rectangles and prove to me that your lines of symmetry are where they are so that they will see that that is not a line of symmetry. Okay. Do any of these have any fractions that we can see? Do any of them have a unit fraction that we could write? Right? One of these is 1/12 of the whole thing. When I put the line of symmetry down here, this is 1/2, this is 1/2. When I put the other line of symmetry in, then I get a quarter, 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 quarter. I want them to start connecting those pieces that we're teaching them, not just about the unit of area. So ask them those kinds of questions so that they're continuously bringing it back and that they're practicing on it. And in this one, we're asking them to bring back their plotting. So on the back side, we would like them to just label it, call this their x-axis, call this their y, or their vertical and horizontal, doesn't even have to be labeled x and y. Plot these points, join them, and then answer the questions about what's the rectangle cover, how much, what's the perimeter of that rectangle, could you find a line of symmetry for that rectangle, is there more than one line of symmetry for that rectangle? So they're just combining a whole bunch of things and just revisiting as they go along. All right, one of the other ones that's in here is a place value question or place value revisit. It's called dollars and cents. I won't spend the whole time going through this because we have some other things I want to cover here yet. So in dollars and cents, what you'll see is that we give them a template that is expressed in dollars and cents. There's no decimal. I'm not concerned about the decimal at the moment. I'm concerned about can they even add? Can they add, if I say show me 124 and below that show me 256, can they add those up? And the fact that they are in money, I can see that ones go together. I can see that $10 bills, which are tens, go together. I can see that $100 bills, which are hundreds, go together. I can see that $1,000 bills go with thousands. So it makes the place value visual. And it also helps those kids who just can't get why we have to line them up to see them. Purples go with purples, browns go with browns, coins go with coins. And then we can introduce cents over here. We don't necessarily need the decimal. What I need to remind them of is how many pennies again to a dime? 10. Okay, right. So every time you have more than 10, you need to trade them in and go over to a dime, just like they would do trading on this side. So this whole thing will go through that and give you examples of it. There is a template in here as well for you to get one of these. I cut them in strips, but they're on 11 by 17 paper. so that you can cut off, I think there's 6 or 7 on one of those sheets that you can use them for the class. So really what I've set up there is a base 10 system. So I'm using this in lieu of the base 10 blocks because right now I want them to A, show me they know the money, B, leverage it so that they can see what they're lining up without me telling them. And I also want to use the money to convert so that they have a reason to convert and understand what that's all about. I'm converting 10 dimes because it gives me a loonie and it wipes off everything that I have. I start again. So that's the conversation we want with students. And the more they can do this and the faster they can do this, the better adders and subtractors are going to come. It makes a huge difference. If you've been using base 10 blocks, the struggles that you come into is when you introduce the decimal. Because the base 10 block requires us then to make the exception to the rule. We're going to call a flat a 1 so that we can use the rod and the unit. And that is so confusing for some of our kids. So in one of the other teams that I worked with, they didn't do that. This is from another country. They said, why do you guys do that? And I said, well, what do you guys do? And they said, well, we take the flat and flip it over. We don't rename them. We don't give them a new name. We just leave them the same way that they always were. The 1's a 1, a 10, 100, 1,000. Flip this one over and we ask the students, how many holes are there? 100. Oh, and how many pennies do I need to make that next loonie over here? 100. And how many rows are there on that? 10. What does that give me? 10 dimes. So really this flat gives me 10 dimes and 100 holes for 100 pennies. So I can have 2 dimes and 3 pennies to represent 23 cents. And that makes a lot of sense. And it makes it very easy for the students to go through and figure out what the values are. Okay. These are not new to you. I brought them back because, again, if somebody is new, just a reason to convert. Sometimes kids ask the question for base 10 blocks, why do I have to trade? Like, who really cares? Other than you're going to run out. That would be one reason to care. They don't understand what it is. And it's just because there's no meaning to them. They're abstract. They're excellent tools, but they're abstract. So if I do it here first, then when I ask you to trade 10 little units for a rod, not a problem. You got it. You figured out why you might do something like that. So that's all that these slides will show you. And again, you're going to use these to talk about place value. Show me $46. Show me $22 below. How much money do you have altogether? I wouldn't use these if I was doing the base 10 system because I just want them to use these. But again, can I convert? Can I trade? Can I make it easier? I just hate walking around with extra stuff in my pocket. Well, I could trade 5 of the 10s for a 50. I could trade some of these toonies in or loonies in for a toonie. That's about the best I can do. But really, we want to stay here. We want to stay in the base 10 world. We want to ask them these questions. What's the number? 36. What digits in the tens position? 3. How many 10s are there? Well, I can see them. 10, 2, 20, 30. There's 3 of them. How many 1s in the number? Is not 6. Is 36. How many 1s in the number? Is if you only could pay me in loonies, how many loonies would you have to give me? If I said what number is in the 1's position, that would be 6. So they need to understand difference between position and value. And there's a number of additional examples of this, okay, where they go into the hundreds. Here's an example of how I might introduce decimals. If I've never done dollars and cents before and then want to introduce the decimal, I can say, you know, those cents, the decimal simply divides the cent side that we're trying to build enough to get another loonie from the dollar sides where we've already got the dollars, all right, in different forms. So I could have, what's the question? $13.15. And I'm going to add to that $13.15. So that means that the decimal helps to separate for me everything on this side are the cents. Everything on this side are the dollars. And just again, because some of our kids, they get lost in that. So this is really what you're doing. You're trading the base 10 conversation initially just for a money conversation. Nothing earth-shattering, that's for sure. There are a couple of resources here that I want to point out to you. First of all of you have books in your schools. So a lot of times when we get asked, you know, what book should we buy? Well, first of all, you don't have a book that's been approved, but secondly, you've got it. We've actually got it. What the hookup and the holdup is is it's going to take some time to figure out what page am I supposed to be working on. So I have done that work in the CPAR documents for divisions 2. I've gone through all the resources that you have, including the junior highs where we get things downloaded from junior high. And I'm showing you what pages match to what you're teaching in those cusps. So that would give you another set of examples, would give you a couple of sets of questions, etc. So find which books you have in the school. If you've got both, bring them both. That just gives you more examples that you can use. This here is from Core Knowledge, and it is a teacher's guide and a student book. And the student books are usually about 25, maybe 30 pages. The student teacher's guide could be up to 100 pages. They provide you with a lesson. They provide you with PowerPoints. They give you everything under the sun that you could think of. And if I can find some that are good matches to what it was you were working on in this particular part of the year, then I've included them in here. So just check this out. Again, this is not use these. It's if you need it. If you don't need it, ignore all this. The CPAR documents I will take you to because these are being posted now. These are the ones that we showed you earlier in the year where we said this work was being done to try and help sort of facilitate a place that you could go to maybe get an additional activity or to get a formative or a summative assessment or to find some resources, just sort of in one location. They are done by organizing idea. In this case, number is your organizing idea, but you have several learner outcomes in number. So for each learner outcome, not cusp, each learner outcome, there's a separate document. So here's number 1, here's number 2, 3 is getting really close to being done as well, and 4 is on the heels as well. So they're always just going to be added on to the bottom. And in each one of these, depending on how many rows of cusps you have, there will be multiple sets of information. So everyone looks the same. I'm going to fly through this one. And in this case, what you'll start with is this is number 1 for grade 5. You have an introductory section up here, which gives you resources that you can attach to that are generic, that either take you to New Learn Alberta or to take you to ARPDC or take you to recording to show you how to step through here, or some usable assessment templates that you might want to use, etc. Below that, we take each of the bits of information and we break it out by cusp. So we see that 5 and 1 only had one row of knowledge, understanding, skills, and procedures. Okay? If that's all it had, that's all that you're going to see. And so for each cusp, you will have pre-assessments. So if your school happens to use the Nelson pre-assessments, or for those who do, I've curated which ones fit to what you're about to unpack. So where would I find them? What page would I go to? Vocabulary is here. I know I can statements are also listed, as well as if there's some learning recoveries that might need to be enhanced, there's some suggestions there. Below that is where the cusp is. Here's the cusp. And you're not seeing all of the skills and procedures because you have to teach the skill and procedure and assess it at the same time. So what we did is we broke up your cusp. The knowledge and understanding is there, but we broke it up so that each one of these skills will have its own row of information. It gets its own achievement indicator, those you're familiar with. It has its own illustrative examples. And then on the right-hand side, you have formative assessments that you are able, formative, not summative, right? This is your touch points. Like, do they have it? Are they getting it? Are they kind of where they should be? Or I need to stay and do a little bit more work. So you're going to have all these examples that are going to just keep coming until we get to the next skill. And if the skill is something that should be merged together with another one, we did. Here's an example. So these two have been put together. Here's your achievement indicator. Here are the new examples that will go with that skill. Here are your assessments. The assessments have been sectioned out by surface and deep. Surface being that just surface level teaching, basic, just taught you brand new terminology, you got it. And if you don't, then I need to stop there for a bit. If I think they're beyond just the surface level, they're ready to do some connections, those are what we've tagged as deep. Any one of the ones that you click on here will download to your computer. You can preview them if you want it. Great. If you don't want it, just close it out. If you want to keep it, just click on the blue button that's on there and it will download it to your computer in an editable form. So if you say, I want to add a couple of questions I had on my test to that, great, you got it. You just add it in there and do whatever you need. So it goes like this all the way down until you are done all of your skills that were in that row of cusp. And then below it will be a section of resources. Now, if there was another row of cusps in your learner outcome, after we're done resources, it all starts again. So the more cusp you have, the bigger the document becomes. So in resources, we've linked mathology because all of you have access to mathology. If you have math up in your school or school division, we've linked what those pieces are that are directly related to this numbered outcome. Same thing with your existing textbooks. You're seeing them show up here again. We see websites that would be helpful in this particular piece that you're teaching. We also have an NCETM that is from the United Kingdom. The United Kingdom has given us permission to use some of the resources that they created with their teachers. And if there's a link that fits to what you're teaching, we included the link in here. But you should have a look at those because they're really good. If you're looking for some inclusion and differentiation, those are found right in here. And then if you are looking for resources that were developed by other school divisions and they were willing to share them, we've listed them in here. These are watermarked in progress because they're going to continuously be updated. These are not a done deal. So you always have to check back and just see, is there anything been added into it or not? And I'll show you a fast way to check that. Karen Bloomhagen has gone in and curated all of the gizmos that fit to your grade, to your learner outcome that that you were teaching. And then below that, there's an Indigenous connections. Those are going to be also fit into the main part where the activities are in other documents. You'll see that coming up. So if there was another cusp, all of this would repeat. There isn't. So the final piece will always be a literature piece. Are there any books that we could find that fit here that you might want as a classroom book or read to the students that might give them some activities that they have to do linked to what you just taught me? So those CPAR documents are going to be created for every math grade, every learner outcome. We're going to keep moving forward and just keeping those going. And when you find the document, you'll see at the top right-hand corner is a date. And if you can just kind of mentally think, oh, it's been, November when I went in there, I saw it. Oh, I see December dates are on there. Then there's been some updates in there. We can't possibly keep sending out emails saying we've updated this, we've updated that. There's just too many of them because we're doing them in math and we're doing them in science. The ELAL for K-3 and 4-6 are also already posted. So you will find those on the ARPDC website. And you just need to put in CPAR, C-P-A-R, which is what was linked in your document right here. You see it right there. Okay, I hyperlinked it directly to the math ones, but if you just put that in, they'll all come up. You'll find them, every one of them. Additional resources that you might find helpful right now in what we were just talking about are found here from the Ontario map. Again, these are here if you need them. Don't use them if you don't need them. And then the work in the unit fractions, I see we're really getting close to time here. So in your work in unit fractions, it says model and express. So students need to be able to model a unit fraction. They need to be able to express any fraction in terms of its unit fraction. So 5/6 is really the same thing as saying 5 groups of 1/6 or 5 times 1/6. Okay, I'm going to skip through the stuff that we had in here for basically what research has told us about fractions. It would be worth going back and having a look in the grade 4 video just towards the end because all of that is recorded. I just want to be cognizant of time. But there is a lot of research that's been done now on fractions, and there's a lot that we could just tweak a little bit now that we're starting a new curriculum. If we could just be observant of some of those things, we might have students that are a little bit more comfortable and more successful with the fractions. So that's an important piece that we want them to have. So one of the key pieces is don't just jump to and tell me what a fraction is. Don't just say a fraction is a number that's over this. It's written like this. This is called the numerator, which is all true. This is the denominator. Maybe just talk in terms of how it's related. It's a relationship between two numbers. And they're related somehow. How are they related? Well, maybe the top number is part of that. Maybe it's a set, whatever, right? So we just want to start there. There is no rush to talk about fractions symbolically and giving me numerators and denominators and things like that. Eventually, obviously, you're going to get there for grade 5. Most of them are going to come to you in grade 4, having already known that. But we really want to spend the time making sure that they understand what it is that they learned. So the unit fraction could be done with money. You could do it with dimes on a number line, change my numbers to cents instead of dollars, or just numbers. And then I can have the conversation about what dime is this? Well, this is the first dime out of a total of possible 10. 10 dimes to make a loonie. Now, I know I'm using the language out of possible, but just for explanation's sake right now, that's really what I'm asking of them. What is this? Well, this is the first dime that shows up on the number line. And when I go through this first dime, I can label it as 1 out of 10 possible dimes that I see. I see them right here. This would be my second out of a possible 10. This is my third out of a possible 10, my fourth out of a possible 10. So using that 1/10, and I would use that language 1/10, this is the jump of 1/10. That's what it looks like. Here's another 1/10 jump. Here's another 1/10 jump. Here's another 1/10 jump, and so on. So one of the activities that I have included in here is that the students are going to fill out a sheet and work on unit fractions based on jumping. And we're going to use this as our model. I figured out I had 10 dimes. This one was my first out of 10 hops or jumps that I was going to do. And I could write it like this. And some of our students liked it writing like this. They'll say, this is my second 1 out of 10, my third 1 out of 10. But there are many students who said, this is my second, put 2, and then put a bracket 1/10 jump. This is my third 1/10 jump. This is my fourth 1/10 jump. Fine. In fact, it's even better for what you have to do in grade 5. So I could ask them to do the nickels. I could ask them to do the pennies. I could ask them to do the quarters, all the same way, and see what do they find on their number line. And you'll see those displayed in the slide deck here, where you see them all done, the pennies, the nickels, dimes, and quarters all onto one sheet, and then ask them to compare what they saw at 50 cents. What kind of fractions did they see? And they didn't all look the same, and yet they all represented 50 cents. Or what happened at the end? They all represented 100 or 1, but they didn't look the same. So it's just unpacking that, what should be good understanding already coming out of grade 3 and 4. This is the sheet I was referring to, and I might model the first one with them. This is my 0, this is my 1. How many hops will I need to get, or jumps do I need to make to get to the end? Well, I need 1, 2. So this will be my first out of 2 hops. This will be my second out of 2 hops. That's as far as I'm going to go with them, because now I want them to count their hops and fill in the rest. I could ask them, this is a student sheet that we photocopied. This is what one of the students wrote, but then we also asked them, does any one of those lines represent money? Or any one of those a representation of money? And that's why you see this sitting here. But the quarters are the important one for you in grade 5. Why? Because the quarter allows me to count by 25 cents, and I'm going to see that I'm going to get, I'll go to the quarters here. Let me go to the bottom one. We have this one here. I stepped ahead here. We moved the 1 so that they're over here. And that's what you need to do in grade 5. You need to get them to an improper fraction. And the only way to get them to an improper fraction is either extend the line or just shift where 1 goes. And where 1 goes, here's my quarters on the bottom. Here's my first quarter, my second quarter, my third quarter, my fourth quarter. I'm going to keep hopping though. I now have 5 of those. I have 6 of those. I have 7 of those. I have 8 of those. And the quarter makes it a good conversation because we say, how much is a quarter? 25 cents. So now I have a decimal 25 that I can put in this place. This becomes 50 cents or decimal 50. This one becomes 75. This one becomes $1, 1 decimal 00. Well, then what's happening over here? I have more than I needed to get 1. So I have enough for $1, 1, and I have 1 quarter left over out of a possible 4. So I could write it as a mixed fraction, 1 and 1/4, or I could say, how much money do I have? $1 decimal 25. So we start to transition them from one to the other and back again. Instead of just saying divide by 10, divide by 10. This is what it looks like. just to give them a little bit of time to connect in their own mind. So here you kind of see the work that we did with the students when we started to unpack the conversation. Okay. And some of this you'll find even happens in junior high. You'll see the reference I have here, Math Focus 7. In junior high, this would be an equivalent that I would be able to grab some examples from there as well. So wherever you need them, go ahead and grab them. These are your verbs that you're going to find in the units that we're unpacking right now in these months, and the ones that we've actually done beforehand as well. So here are some sources from the research that was done if you're interested in it. If not, ignore it. And there we are. And I apologize for going over, but I knew there was going to be lots that we have here. So you have your cohort. I am aware that the grade 5 from last time wasn't posted. And I did get a hold of the office to find out. So we will rectify that. But what I am going to do is I'm going to grab the link to the slide deck and at least give that to you right now in the chat box so that you have it. But it will eventually be right up on the ARPDC site so that you don't have to worry about it. And I will get to the bottom of why that's not there. So let me just grab the chat. Okay, if you want to grab that link, and if one of you want to just let me know if it opens for you.